In this example, we're going to evaluate the integral of e to the power x times x squared dx. So if we try to apply the substitution rule, we'll see that it's not going to work, and it can be an extra exercise for you to do, but what will work is the integration by parts formula. So let's apply it here. I'm going to remind myself, and it's always a good thing to do, if you're using formula or certain rule, to have it in front of you. So to help myself, I'm going to write down the integration by parts formula so it's in front of me. I'll put it here. So it goes like this. Integral of u dv equals uv minus integral of v du. And to apply this formula, first I want to represent the left-hand side. Well, I have to represent my integral as the left-hand side of this formula and obtain the right-hand side. So in other words, what I have right now within my integral, I have to represent as u times dv. So let me write this down. So I need to decide what's going to be u and what's going to be dv for my integral. Well, we can start by just assigning u and dv in order of the factors that we have, and see what happens. As we do more examples, we're going to learn what works best, or some good tips, in other words. So, but let's for now try it. If we have no ideas, let's just assign e to the power x to u. So u is e to the power x, and then there's no choice for us but let x squared dx be equal to dv. Now, if you remember, or I guess we can just look at the formula and realize that now to apply this formula, we will have to obtain both v, it's going to be here, and du. So we have u dv, but now we need to obtain just v and then du. Okay, so let's start with du. So if we have u equals to e to the power x, then what's going to be du, differential du? Well, it's the derivative of e to the power x, which is itself e to the power x dx, right? So we find derivative going this way, and then if we have dv equals x squared dx, then to obtain v itself, we have to find antiderivative, or in other words, we have to integrate. So integral of x squared is x to the third power over 3, like that, right? Now, as soon as we obtain all parts, let's try to put this all together into the formula and see what happens. I think I'm going to rewrite my example. Integral of e to the power x squared dx equals u times v. I'm following the formula. U times v. So it's e to the power x times x cubed over 3, right? Minus, so maybe I'll make notes here, so that's u and that's v. And we started, I'll put those notes here as well. So that was u and that part was dv. Okay, and then minus integral v du. V is x cubed over 3, and then du is e to the power x dx, like that. So once we apply a formula, then we can simplify or multiply functions here, but then the next goal will be to integrate or evaluate the integral on the right hand side. And we would hope that that integral that we obtain on the right hand side becomes easier than the one that we started with, right? That's the whole point of applying the formula. But as we look at it right now, we can notice that, well, e to the power x stayed, as in the original example, in the original integral, and x also stayed. And on top of that, well, we used to have power 2, but now we have power 3, so actually things got worse, right? And nothing has improved, but things got worse because power of x got increased. And that's not a good thing, because, well, how do we integrate that? Again, substitution rule would not work. We would have to apply integration by parts. We could try that, but with our choices of u and dv, we can see how things are not improving. And that may happen. In which cases it might happen? Well, it might happen if this method doesn't work at all for this integral, or and that's what happened actually in our case, our choices for u and dv are not the best choices. So remember how we went in order? E to the x was u, and then the remaining part was dv. Well, we didn't have to go in order, or we can now try to do it in different order, in other words. So let's try that. I'm gonna make a note, kind of explain the reason we stopped here. So I'll say this doesn't look any better, right? And for this reason, we're gonna start over again. And in math, that's a common thing to do, right? You try something. If it doesn't work, well, you try something else. So I will rewrite my example one more time. And from learning our mistakes from the first attempt, this is what we're going to do next. Next, as we assign u and dv, we're going to do it differently. So this time, let's say that u is function x squared, and then dv is e to the x dx. So that part is u, and over here that portion is dv. Let's see what happens. Now I have u, I need to find du for the formula. Now here we have to find derivative, right? So derivative of x squared is 2x dx. Okay, so at least like power went down, right? That's a good thing. Now dv, dv is ex to the power e to the power x dx. V itself is going to be antiderivative, right, or integral. Well, integral of e to the power x is itself. Now that stays, but let's see how the right hand side will look like now. Let's follow the formula once again. You should have it in front of you. You don't see it on the screen, but you should have it in front of you at the top of the page. So u times v, u is x squared, and then v is e to the power x, minus integral, and within this integral we should have v du, just v, e to the power x, and du. Du is 2x dx. Now let's see what we have this time. So we still have this integral we need to evaluate, and we still have both e to the power x and x present. However, I think this integral looks better than the original one. And what makes it better? Well, the fact that x is now to the power 1 instead of the original power 2. See how power went down? And that's the good news. That's the improvement. Because what we can do right now, I'm going to rewrite this expression. The only thing I'll do, I will put that constant in the front of the integral, so it's just out of the way. Now, what we need to do right now is to think how to integrate this part, to evaluate this integral. First of all, I can notice once again that I cannot just use the basic integration rule here, right? Since I have a combination or product of two functions, ex and x, I won't be able to use substitution rule. However, I can try to apply integration by parts again now to this integral. And since our choice of u and dv proved to work, in other words, we're reducing the power of x, we can hope that while we do it one more time, once we do it one more time, things will get even better than we have them right now. So let me put notes down here. So we're gonna apply, let me say, apply the integration by parts formula. One more time. And this is a common thing that you can come across when you're applying integration by parts method. You might have to do it a few times until you get down to basic integral. Or there are some exceptions to that, and we'll see them in different examples. But yeah, in this case, we now need to decide again what's going to be u and what's going to be dv. Well, we'll learn our lesson, so I think applying or letting u be equal to x sounds like a good idea, and then dv will be e to the power x dx. So we're doing this similar to our first step when we applied integration by parts at first. Okay, so we have that. Now from here I need to find du. Okay, du is derivative of x dx. Derivative of x is 1, right? So it means that I just am going to have dx. And then if dv is e to the power x dx, then v itself will be antiderivative. So that is, again, e to the power x. Okay, so let's see what we're going to have as we put it all together. So here we have to be careful and not to lose any pieces. So I'm going to copy down everything I have. So first of all, I have x squared e to the power x from the first step, right? Then I have minus 2 times that integral. Well, and that's where we're going to apply integration by parts formula. So I'm going to open brackets, and I will write down the right hand side of the formula inside the brackets. So following the formula, it should be, let me make notes here. So that's u, and I'll say that this part was dv. So according to the formula, we have to multiply u and v. U is x, v is e to the power x, minus integral, and then v du. That's u v, and now minus integral of v du. V is e to the power x, and then du is dx. So that is v du. You have to have formula in front of you for this to make more sense. So make sure you're looking at the formula as you doing that step. Like that. Okay. So we still have integral there, right? Well, we always have when we apply integration by parts method. We will always end up with another integral. But the good news that this time we're looking at the basic integral, right? So that integral we can evaluate using just the basic rules, right? By finding the antiderivative of e to the power x. It means that it's pretty much one more step and we're done. Well, before I do that, I will simplify this expression. In other words, I will distribute -2 so I don't have those brackets. And for that, I have to multiply -2 by each part inside the brackets. So it's -2x e to the power x, and then negative times negative, it's positive, plus 2 integral e to the power x dx. Okay, so the last step is to integrate, evaluate integral of e to the power x, and copying down the rest, the beginning of this expression, plus 2 times, well, antiderivative of e to the power x is itself, e to the power x plus c. So that was this part. Well, and that's the final answer. So that's the result of the integration. I'm going to box that. So this example illustrates a few things. First of all, it illustrates that your success in applying integration by parts method depends on the choice. Well, sometimes, or a lot of times actually, will depend on your choice of u and dv, right? Didn't work first time, worked second time. That's one. Don't be afraid to try things. So if you're not sure what to assign u and dv to, well, just try something. If it doesn't work, you can always rewrite it, right? What's the problem? Okay, so remember that. And second, it's also common when you have to apply this method more than once. So if you applied the formula but you ended up with an interval that you're not able to evaluate using basic rules, basic formulas, then apply integration by parts one more time, or maybe two more times. So it all depends on the complexity of the example, but you might have to do it one or two times. So just see more examples.